All right, so this morning we have Pioneer QX. Excuse me while I move my mic around. It's not cooperating this morning. Pioneer QX 747. So what we have going on with this one is we have a channel imbalance. All inputs. So what I'm going to do this morning is show you the block diagram, and I've worked on a couple of QX 747s with a similar issue. And I'll just take a minute or a couple minutes and kind of describe to you what was going on with the other one. So looking over the block diagram we have, see if I can move this up here. And I'm going to follow the auxiliary, right? The auxiliary signal coming in, and this is the left channel. And this is true of the right channel, right? And the quad channels, you know, we're talking 1, 2, 3, and 4. So the auxiliary signal will pass through, I believe it passes through the matrix assembly. There's some kind of feedback thing. Now, I could be wrong there, so I'm not going to worry about the matrix assembly right now. Where I'm going to focus my energy and effort is I'm going to look at the decoder circuit, I'm going to look at the control amp, and then I'll probably look at the power amp and or maybe the matrix assembly first. I kind of get lost in exactly what's going on with this matrix assembly. And the circuit descriptions are okay, but they're not super detailed. And the schematic is really, the quality of the scan is pretty poor. So it's hard to kind of figure out what's going on and what's connecting to what. The issue with the QX 747 and 949 is they are Pioneer receivers of the generation that used transistors that are prone to failure. 2SA, and it's either, I think it's 2SA 725, 726s, and then 2SC 1312s, 1313s, I think. And, well, I could actually look at what I have going on here, because this will actually list the, 1312s, and then we have, oh, that one doesn't list it, and then we've got, 725s, kind of sprinkled throughout this thing. So what I'm going to do is I'm going to inject a 1 kilohertz tone, and I'm going to start with the decoder circuit, and I'm going to look at the in and the out, right? Figure out if we have balanced signal going in, coming out. Then I'll move on to the tone control, and then, like I said, either the matrix or the power amp. I couldn't tell from the schematic what pins, right, the signal's coming in and going out of, so I'm going to have to kind of just shotgun it. The schematic's a mess. It's not really clear, and there are just, it seems like hundreds of connectors, right, on the schematic, connecting all the boards and showing, like, you know, signal path and all that stuff. So I'm going to speed through that as I do that. Going to get my scope set up first, so I will kind of click away and then come back, and then I'll speed through it and I will let you know what I found. I'm not going to show you the scope. I may, once I get this flipped over and I get my scope set up, I will probably talk about specifically what I'm doing. In terms of the boards. So let me get this set up real quick and I'll come right back. Well, to make it even a little more convoluted, I'm going to zoom in just a little bit here. Make it a little more convoluted, the service manual that I pulled, and sorry about that. Service manual that I pulled and the schematic don't match. The board numbers are different, the pinouts are slightly different. Which, again, with the service manual, it was going to be hard to figure out exactly where everything is kind of passing through anyway. And this is on. Let me turn it off. I don't want to zap myself. But as far as I can tell, matrix board, decoder board, power supply, amps. On the other side are the FM board, or the tuner boards, and then we have tone controls. Now again, on the last 747 that I worked on, where I had a channel imbalance, what was going on was there was a failed cap on. It was actually in the flat amp. The flat amp is, you know, I don't know where the flat amp is. The flat amp is, I wonder if that might be the flat amp, is phono. This could actually be the flat amp. Again, none of my numbers are matching up to this. There's another board here that could actually be, that one could actually be the decoder. Yeah, and I know that there was like a service bulletin out there on Hi-Fi Engine, but I didn't pull that down. So anyway, what I'm going to do is I'm going to start probing here. I've got my 1 kilohertz tone going in through auxiliary, and I'm going to start poking around and seeing if I can figure out where that signal is entering and leaving a board where it's coming in even and then it's leaving uneven. And the way I'm going to do that is I'm just going to use my probes and carefully poke around in here. So I probably won't put that on camera, but when I find the board where it's coming in and going out uneven, I will let you know what I found. All right, so that was actually pretty easy to identify. So I'm going into the tone control board, and here are the input pins. So signal is coming into the tone control board. It is dead even, right? There's no difference between the two channels. And then when I move the probes to the outs, there's definitely a channel imbalance on the tone control board. So I'm not saying this is the only issue, but it looks like I'm going to start by working on the tone control board. Now to get to that, unfortunately, I need to, let me unplug this and turn off my scope, and we'll come back and we'll retest afterwards. I'm going to have to take the faceplate off of this and do some minor disassembly. Hopefully these knobs will come off all right. So all knobs have to come off, and then you know, the problem with this quad is that you've got all sorts of little tiny knobs all over here, so it's gonna take me a little bit of time to do that. Actually, these aren't coming off too bad, and these were all misaligned anyway. Like there's a little tiny like indicator on there. So I'm gonna get to disassembling this. We will remove that board. Ooh. And I'll swap in some. Well, and you know, here's the deal with this. So when I remove this board, I'm going to find that it is going to be full of bad transistors, and there's likely a failing cap. Now I could go and I could trace the signal and identify exactly which component is causing the issue and replace only that component. You know, that's probably the correct way to do this. But knowing that this is full of bad transistors, and if I'm going to have a board out, I might as well recap it anyway. And I know this is going to be, you know, shotgunning a repair. But, you know, if I'm going to have the board out, if I'm going to go through all the effort of the labor of disassembly and replacing the bad transistors, I might as well recap it. I don't think there are going to be a whole bunch of capacitors on that board. And it may not even fix it anyway, but, you know, again, a kind of economy of effort here. I will kind of replace everything, and then after the fact, after I've replaced everything, then hopefully I will identify the component that's causing the issue. Now, if I do this board, I'm going to do this board, because again, I'm going to have the faceplate off. Those should be the only two boards, I believe, except for possibly that decoder board underneath, if that's what that is. I don't remember if I can get to that from the top or bottom. Power supply board, it's off of the standoff right there. It's not locked in, so I wonder if someone has done some work to this. So anyway, on to disassembly and then replacing those components. All right, so I want to show you some things you need to be aware of. So this has two SC1344s, and those are not, as far as I know, I'm gonna have to check. I don't think those are on the bad transistor list. But these Sanyo sky blue caps are prone to failure. So I am suspecting that one of these is probably bad, and that is probably what's causing our issue. Looks like they're either 1 or 2.2 microfarad. So I'm going to replace those. And what I'll do is I'll pull those, test them. If I find the culprit, I'll let you know. Then I'll pull the oranges, test them. If I find the culprit, I'll let you know. We do have a couple of other caps here. And then there are those transistors, which, unless they're on the bad transistor list, I won't touch those. Assuming that whatever I do with these caps resolves the issue. So I'm going to grab some caps and do that real quick. All right, so we've got two caps on the affected channel. So it was the right channel that had lower output than the left. Both of these, while testing, in terms of the capacitance, I guess, they were close, right? So we had like 1.1 and then we had 2.6, and this was a 2.2, but really high ESR on both. On the right channel, only one of the caps had really high ESR and the other one was fine. So I am thinking that it was probably, and again, these are also recommended to be replaced. I'm thinking it was those sky blue caps. I didn't check the transistors to see if they were on the bad transistor list, which I will be doing, but what I want to do now is just test this. So I'm going to throw this back together and then test and see if I took care of that channel imbalance. See how close we are. I need to find, oh, there they are. I'm going to put at least one of these on. I don't need to put both on, but I will fire up my signal generator. Because that's not hitting anything. No wires were broken. Instead of cutting over, I'll just go ahead and do this now. Power on. Oh, I don't have it plugged in. Power on. And let me get my probes on here. Man, I made a huge mess of my bench. Trying to find my probes. Okay. And I would show you my scope, but it's just sitting over here. You'll have to take my word for it. All right, so here we should have in and in. All right. Okay, perfectly balanced between the two channels. And now we're going to do out and out. Perfectly balanced between the two channels. So, on that board, it was those two caps for the right channel that were failing. Now again, I'm going to go and I'm going to, while I have the bottom off, just turned off my, you know what, maybe I should, well, let's see. I don't know if the signal is passing through the other tone control board because I don't have it in quad. So let me just see what I can see here. So we've got, yeah, we have nothing going through this other board. So I'm not going to assume that anything is wrong with that board, but what I am going to do is preemptively change the 2 Sanyo, or the 4 Sanyo caps. I would assume that there are 4 Sanyo caps on this board as well. You know, I could recap the board, which I will probably do. I need to check those transistors, but that's my lovely wife. So, sorry, my wife was leaving, so I had to say goodbye to her as she went off to do some things today. So 1344s are on the bad transistor list, so I am going to be replacing those, but I'm going to pop this other board out and do that as well. And although I didn't zoom in on the scope, I see in this shot you may be able to make out the channel imbalance when I started and the fact that there is no channel imbalance when I finished. I didn't zoom in specifically on the scope, and I probably should have, but I didn't want to move my camera. I was being lazy. I didn't want to have to do that. So anyway, I bet this other tone control board is in a similar configuration. Now I could pull the orange caps and I can pull the black caps out of here, and since these are so easy to get to, I probably won't. And the customer is not paying for me to do a complete recap on this. So it was really just to identify that. I will do at least the blue caps on both of these boards. Assuming this other board has the same configuration and layout. Oh man, that's a tight fit. And because of the way these boards are positioned, I'm going to have to check to make sure I didn't break a wire. But this, yeah, so they're the same. So I'm going to have to replace the blue caps on this side. I will test them though and then show you how they measure. But I guess I probably didn't really illustrate this. So let me grab... I think there was one of these caps that was good. So here's a 1 microfarad 25 volts. So I'm going to put it on my tester and it's going to bing, right? Or it's going to beep. So the ESR is 20. The capacitance is 1.08. The ESR is 20, and that's way high. Notice the noise that makes. That's not a happy ding, right? And then this one, I think, was the good one, if I remember right. And it could be the 25, but this is a 1. Oh, that one's bad too. So that's 12 ESR, and that was not a happy ding. So that's a happy ding, right? ESR is 2.4 ohms, capacitance 2.64. Let's listen to this one, and this one will be an unhappy ding, right? ESR was too high. So that's how I determine it. In case you're not familiar with how these inexpensive peak testers work. So I'm going to go on to replacing the transistors on both of these boards, the caps on both these boards. I will test these though. I'm going to do these caps first, just to, let me zoom in a little bit, just to let you know how these fared in terms of testing, and then I'll do the caps. I may do the orange caps as well. Again, it's like, what does the customer want to pay for? And they don't want to pay for a complete recap. So, but you know, I'm at least going to get rid of these while I have this thing upside down and apart. So I'll be back when I test those blue caps in this other tone control board. So this was the front and this is the rear tone control. So anyway. All right, so let's test these. And, you know, even though you may come across one of these 747s and You know, it may have an issue with channel imbalance. So, you know, that's bad. So that's high ESR. And how do I know if it's high ESR? Well, number one, I listen to the beep. And number two, I don't immediately see it, but this tester actually comes with a little, oh, there it is. It's way over here. This tester in the instruction manual comes with the chart. So you can look up the capacitance and then what the normal, right, the median, the average ESR values are. So you can kind of determine looking at that chart as well. So first one was bad, high ESR. So this tone control board would have had the same issue. What I was starting to say was, if you have a channel imbalance on one of these, so that one was good. So let's say it's the phono board, or it's, you know, you can see all the powder blue caps sprinkled throughout here. Those are the most likely suspects. And then I would move on to the transistors, right? Now that ESR was high, but it wasn't crazy high. It was 5.7. So what would have happened in 4-channel mode, right? That's a little bit high too. And that cap, yeah, that cap was a little bit high. There would have been the same issue, right? There would have been a channel imbalance. So what I'm going to continue doing is I'm going to change out these transistors and change out all those transistors. Since I have the boards out, I'm probably going to leave the other caps for right now. These are 2SC 1344s. They're going to be replaced with KSC 1845s. And I will need to check the pin out on these. Luckily the boards are marked and they're all consistent. Oh, one thing that was interesting was a trace on both of these. So on this 1 microfarad cap, the trace lifted in the same spot on both boards, which was interesting, just for that one cap and just for the positive leg. So I thought that was kind of weird. So anyway, on to replacing these transistors. I don't think I'm going to record this. This is just going to be the same kind of stuff that you just saw, but I will come back around and talk about what I did or if I found out anything else. All right, so got that all squared away, and let me just, I know I didn't do it before, but I got balanced sound out of both channels, confirmed with the scope. But I don't know if you heard that, so let's go on to the next thing we're going to troubleshoot on this. And this, I guess I really hadn't noticed, but so we got some music playing. When I turn it off, hear that pop. So we're going to have to figure out what that pop is. I would suspect probably because it's coming out of both channels, I suspect something in the power supply. Something common to both channels. It doesn't necessarily have to be in the power supply, but that is kind of what I immediately suspect. And then I have not gone in to replace the transistors in the tone control board, which I am going to do as well. Those 1344s are known to get a little staticky and bursty, and what had happened was I put it back together and then I did a sound check and I wasn't getting any sound, so I had to go and figure out what was going on. And you know, these controls, sorry, not the controls, the push button switches are really hard to get to. So, and I guess I didn't say this initially, but I went through and cleaned all the controls when I had the channel imbalance to make sure it wasn't just a dirty control. But I didn't do a very good job on these switches here. They're super difficult to get to. You have to, it's like major disassembly, so I had to get in here with the face off and just kind of spray and pray a little bit, and now I've got both channels back. So anyway, I think I'm going to go on to troubleshooting that pop at shutoff. I'm going to confirm that it is both channels. I'm almost positive it's both channels. So again, that leads me to suspect the power supply initially, or something that's common to both channels. Doesn't have to be the power supply, but that's at least what I'm thinking right now. You know, the pop noises are kind of hard to isolate. At least I have a hard time isolating them. So we figure out what I'm going to do next, and then get to it and see if I can figure that out. All right, so this has been the project from you know where, and I opted to not record any of it, but there's a good probably 4 to 5 hours in this thing, and that's just the nature of a quad. It's the nature of the 747 and the 949, and I want to explain to you what I've done, because I'm at the point now where it's finished. Minus one cap. Oh, my alarm's went off. Minus one cap that I just got in the mail, so I need to replace that one in the power supply. But if you look, you can see that I've recapped the entire thing, to include the tone control boards, the protection circuit, this matrix decoder combo board, and by the way, this is a 747A and not a 747, and then the power supply board. I have not touched the FM section. I don't plan on touching the FM section. Oh, and I also did the amplifier board. So here's why I did all of that, and it kind of drove me crazy. Well, I fixed the channel imbalance by replacing the bad cap in this tone control board, right? Those blue Sanyo caps. And I replaced, you can see this pile of caps over here. All but probably 3 or 4 of the blue Sanyo caps were bad. Now, what I did was I replaced all of the blue Sanyo caps, right, on all of the boards. I replaced all the bad transistors on all the boards. And then I gave it a listen. And I discovered that there was a lack of bass on the right channel. So I thought, now all the blue caps are replaced, and my assumption is that all of those are in the signal path. I just haven't looked at the service manual to confirm. So I thought, well, you know, there are a handful, you know, maybe 20 caps here, and, you know, maybe I think 6 and 6, and, you know, a couple of caps here. What I found during the process of replacing the rest of the capacitors is the light blue or the sky blue Sanyo caps aren't the only caps that were bad, and I mean way bad. So what it was, the lack of bass on the right channel was one of these, it was a 1 microfarad cap. It had a high ESR of like 12. So I replaced that one, and I was testing as I went, because this board, I could release it and then, you know, replace a couple of components and then, you know, test it out. And it was that cap and a couple of other ones. All the other caps were good in that little batch. So what I would do is I would do a section at a time. Like, you know, I would go, you know, maybe to this point, and then to this point, and then to this point. And it was the only cap that was bad. So the lack of bass on the right channel was caused by just a regular, and when I say regular, I mean a non-blue Sanyo cap. And this was a complete shotgun. I was also trying to track down a pop, and I've discovered where the pop is, but I was also replacing caps, trying to figure out where that was. And, you know, like a pop at shut off is, to me, is kind of a hard thing to track down. So anyway, to make a long story short, what I was hoping was going to be a quick repair ended up being a complete recap. Now, the reason why I recapped it, and when I started, I said, well, I was talking to the owner. Well, after some conversation with the owner, I just said, listen, this is going to be an expensive endeavor, right? So you need to understand that I've repaired the channel imbalance, or I could do that easily. However, I cannot guarantee reliability without going through and replacing all of the other Sanyo caps and some of the other electrolytics. So the owner opted to trade this to 402 vinyl for another piece of equipment. That's a good cap. Another piece of equipment. So now this belongs to 402 vinyl, and you know, I just told the shop owner that, hey, I'm just going to go through and recap it. That way, when I put it out, I'm sure it's going to be good. And but there were lots of little gremlins, and I'm not surprised that the channel imbalance was caused by just a plain Jane electrolytic and not one of those sky blue caps. But I really thought for sure once I got rid of those and the bad transistors that it was going to be good. However, it wasn't. You know, the amp board, I do a repair on I think it was another 747 or something like that, where I believe I show how to take this apart and pull that amplifier assembly out. If not, you can find other videos that talk about that. So anyway, completely recapped. Pioneer QX747A sounds fantastic. Lots of work went into this. You know, with the quad, it's kind of double your pleasure in terms of components. Roughly double your pleasure, right? You have double the components, but this thing should run really well for a long time to come. So anyway, that's going to wrap it up for this QX747. I'm not doing anything with the lamps. The lamps seem okay. I should probably replace them with LEDs. I may do that. I still have this one cap I got to do, which I'll get to probably this afternoon. But I'm going to wrap this video up for now. So I know it was a short one. I didn't really show a lot of anything, but I really didn't intend on going that deep into it. And honestly, I don't want to waste memory on the camera, right? Just by speeding through me going through every single board and me going through this convoluted troubleshooting process, ultimately which resulted in me recapping the whole damn thing. So as always, if you like what you see, like it, subscribe, and I will catch you in the next video. I will be doing a gear review on this. It'll probably come out, I don't know if it'll probably be well after I do the service video. So there will be one of those forthcoming. All right, see you in the next video.